Alright guys, hello. Today we're doing some more geometric proofs here. They're going to still have some of the algebraic idea that we did in the last video notes, but we're going to kind of do a little bit more for different, more reasons that you can add to that list of reasons we have. And these are going to be more of terms from geometry. Alright, so the first one here is actually an example of the segment addition postulate. Alright, so this is what a lot of proofs are going to be utilizing as the segment addition one. These quickly turn into an algebraic one. So what they tell us here is our given, we actually have three different givens here. It says that KL equals x plus 3, LM equals 2x minus 1, and that KM equals 5x minus 4. So what I do is I always draw a picture. Like I said, I'm a very visual learner. I have to see it. And I'm going to mark up my picture as much as I can. So it tells me that KL is x plus 3. It tells me that LM is 2x minus 1. And that Km is 5x minus 4. And our goal is to prove that KL equals 6. Now, in order to prove that KL, this segment here, is 6, we're probably going to have to do what first? Hopefully you're saying solve for x first. So we have to make some equations to solve for x. Then we're going to take the x value and we're going to plug it back in. All right, so let's hit our proof here. Again, we have a nice two-column proof here. Our first statement, they gave us all of this stuff right here. All right, where did they get all this information from? They got it from the given, so our reason is given. Up next, we probably need an equation. All right, so what we have to do here is most of us would probably want to jump straight into saying x plus 3 plus 2x minus 1 equals 5x minus 4, which is awesome and great, and I love that we're thinking that, but we have to do a couple of steps and proofs. Now, this may seem tedious, all right, but we have to explain why we know to do that. I know we are smart and we just know it, but at some point, I taught you how to do all that. All right, so how I know that is I am going to take the segment KL, and I'm going to add it to the other segment LM, and that should give me the whole segment of Km. Why I know this is actually the segment addition postulate. We learned this back in Unit 1. You'll see I shorthand a lot. All right, so this segment addition postulate. Now that I know that, we can start actually making an equation. We know what KL equals. All right, KL is actually x plus 3. I'm going to do this one at a time here. So what is that called when I just replace the value there? Correct. It's substitution. Okay, I'm going to do the same thing to LM now. So we've got x plus 3 plus my LM value is 2x minus 1. That again is substitution. If I'm going to replace the Km value, then one more round of substitution there. If you wanted to, you could do this all in one massive step. I'm okay with that. I just wanted to show you why I was doing it. All right, we're looking at this equation now. This is all algebraic from here on out. What would you guys do next? I'm hoping you're saying let's combine some like terms, because on that left-hand side, I think we have terms that we can combine. I see an x and a 2x, so that would give me 3x. I also see a 3 and a negative 1, which would give me a 2. Do we remember what the reason is when we combine like terms? What is that called? Simplify. When you combine like terms. All right, now we got to solve for x. Looking here, let's subtract that 3x from both sides. So we're going to move that 3x over. So on the left-hand side, I'm going to have 2 left over. I have 5x minus that 3x, which should give me 2x. What I did there, I subtracted something, right? So that's going to be the subtraction property of equality. By the way, you do not have to write this POE every time. I'm not going to take off points. All right, if you don't write out, I'm okay with that, but let's try to get in the habit of writing as much as we can in the beginning. All right, we've done that. Now what would you guys do? Yeah, I would add that 4 to both sides. When I add that 4 over, I get 6 equals 2x. That would be the addition property of equality. All right, up next here, I think we should divide by 2. I get x equals, that 3 equals x there. That's the division property of equality. But we're not done here because our goal wasn't to solve for x. Remember, our goal up here is to prove that KL equals 6. So now that we know that x equals 3, what should we do with that x value? We should plug it in, and we should plug it in to the KL up here. So we're going to have to write that out. We're going to say that KL is x plus 3, but we're smart and we just found out what x was. We're going to plug that in. Okay. What is it called when you plug something in? Substitution. All right. Here we're going to add our like terms. What's 3 plus 3? 6. What's it called when you add like terms? Simplify. Awesome. We've just done our first proof. Woof. It's a long one, right? All right. But most of these we used the new thing of that segment addition once, and from then on it was just algebraic stuff. All right. Let's try this one. This is another segment addition or segment example here. All right, just a little different. It says that our given is point B is the midpoint of AC, point C is the midpoint of BD, and our goal is to prove that AB, that symbol right there, remember, is congruent to CD. All right, so starting off here, our first statement was that B is the midpoint of AC. All right, so it's telling us that B right here is the midpoint of that segment AC. If you remember, what do midpoints do? They cut the segment in half, so I know that this half is the same as that half. All right, so my first reason here is going to be given, because that was one of my given statements. In this example, we have 2 of them, so we're going to use this reason twice. All right, this next one kind of gives this to us. It tells us the reason is the definition of midpoint. All right, and we're looking at what I said in my picture here. Well, if B is the midpoint, I know that either side of that segment, all right, is equal. So I know that AB equals BC. And my reason would be the midpoint. So whenever you're given a midpoint, you're going to be utilizing this reason at some point. All right, this next one says the reason was given. So it's probably going to tell us the next reason. The next given statement here is C is the midpoint of BD. Okay, C is the midpoint of BD, and it's given. Then it told us BC. So BC is the same as CD. Well, why do we know that they were the same? Because C was the midpoint. So my reason is going to be the definition of midpoint. Okay. Now, if you look here, our goal here is to prove that AB is the same as CD. And we have equations here. We know that AB equals BC. And we know that BC equals CD. You notice both of those equations have BC in common. So we can combine those into one. Instead of saying AB equals BC and that CD also equals BC, we can say those equal to each other. I can say that AB is equal to CD. And my reason here is the transitive property. So we took 2 equations and merged them into one. This next one, if you look, the only thing that's changing from statement 5 to statement 6 is now we're saying that they're congruent. All right, this is just the definition of congruent. So another new one for us here. Okay, so we learned 2 new ones here. We learned the definition of the midpoint in this example and the definition of congruent. Oops. Sorry, guys. All right, up here we're going to do an example with linear pairs. Remember, a linear pair are 2 angles that are adjacent, aka next to, and that equal 180. All right, they're supplementary. So we are given that angle 1 and angle 4 are a linear pair. All right, look at our picture here, angle 1 and angle 4. Yep, those are a linear pair. If you look at here, they make that straight line. Perfect. All right, and we're also given that angle 1 and angle 3 add up to 180. Our goal is to prove that angle 3 is congruent to angle 4. Cool, awesome. All right, let's dive in here. It says the first statement is angle 1 and angle 4 are linear pair. Well, how do we know that? It was one of our givens. Now remember, all right, it says here, definition of linear pair. So we're going to use what the linear pair is and make something. The thing is, what do we know about linear pairs? We know they're next to each other, they're adjacent, and they equal to what? They equal to 180. So I could say that the measurement of angle 1 plus the measurement of angle 4 equals 180. Okay. The next one, the reason says it's given. We'll look up at our givens. We already did this first one. That's good to go. The second one we haven't talked about yet. The measurement of angle 1 plus the measurement of angle 3 equals 180. Now, if you look at our goal is to get 3 and 4 by themselves in one big equation. So we're going to have to merge these two equations. What do you notice about those two equations? They both have angle 1 in them, and they both equal to 180. If they equal the exact same thing, can't we set them equal to each other? So I would say the measurement of angle 1 plus the measurement of angle 4 equals the measurement of angle 1 plus the measurement of angle 3. All right, this could be substitution. This could be a transitive. I'm just going to call it substitution for this. It could be either one, though. I'm not going to be too picky when you guys are using substitution and transitive for the purposes of my class. All right, then we went from step 4, that big long equation, to step 5, just angle 3 equals the measurement of angle 4. And how did we do that? So you notice, how do we go from step 4 to step 5? What changes? For me, it looks like they got rid of the measurement of angle 1 on both sides. How do we move that from one side to the next? Well, if I subtracted the measurement of angle 1 from both sides, all right, they would reduce down, they would cancel each other out. They would no longer be there. All right, so this is actually a subtraction. So we subtracted it from both sides. All right, and our proof will be our last statement. So our proof is just that angle 3 is congruent to angle 4. And that reason is the definition of congruence. Whenever you see it going from an equal sign to a congruent sign or vice versa, it's just going to be that reason. So now we have another new reason, definition of linear pair. All right, last one here. It says angle addition postulate. This is very similar to the segment addition postulate. We're going to be seeing this a lot. So when we take two angles, we add them up to equal the whole big angle. All right, it's given that BD bisects angle ABC, and it gives us the measurement of angle ABD is x plus 8, and the measurement of angle ABC is 4x plus 2. What I need to do is, I'm a visual person, I got to draw a picture out. So I'm going to draw my angle. This is angle A, BC. And it's getting bisected, which means it's getting cut in half by BD. It told us that ABD was x plus 8. And that ABC, the whole angle, is 4x plus 2. It did not give us what DBC was, but we're going to be able to figure some things out from here. All right, for this one, I gave you all the statements. Alrighty, so we just have to kind of plug in our reasons. So the first one says, BD bisects angle ABC. How did we know that? It was in our givens right here, so that's going to be given. All right, it then tells me, let me change my color here, that the measurement of angle ABD, so I'm going to trace my angle, measurement of ABD equals the measurement of DBC. Well, how did I know that those two things were equal? It's because it said the word bisect, all right? I know they're equal because that thing is bisecting it. So the reason here would be the definition of an angle bisector. Okay, so I know that the two angles are equal because I bisect the angles. So whenever you see the word bisect, you're going to be using this reason. Up next, it says the measurement of angle ABD plus the measurement of angle DBC, the other little part, equals the whole big angle of ABC. All right, so I'm taking part of my angles and adding them up. That would be your angle addition postulate. Okay. What is changing between these two steps? Does anything look different? Hopefully you're saying, well, this looks different. We replaced the measurement of angle DBC with the measurement of angle ABD. And the reason we did that is because they're equal to each other, because this angle bisector, so this would be substitution, because I replaced it. Okay. Up next, it says the measurement of angle ABD equals x plus 8. Where did they get that information from? Oh, it was one of our givens. So you notice givens can be later on in the proof as well. All right, next one says the measurement of angle ABC was 4x plus 2. That was also one of our givens. And then it went and it made this equation. All right, x plus 8 plus x plus 8 equals 4x plus 2. So it took this equation right here. All right, and it plugged in all of this information from the previous two steps. So that would be a substitution. Okay. Up next, it looks like they combined like terms. They added those x's together, and they took the 8s and they combined them, so that would be simplified because you're combining like terms. So now we have 2x plus 16 equals 4x plus 2. From here to here, it looks like they subtracted that 2x from both sides. So this would be subtraction. Whoops, sorry guys. All right, after that, it looks like they subtracted that 2 from both sides as well. So it looks like it's another subtraction. It looks like we then divided by 2. Okay, and remember, we weren't trying to solve for x. Again, our goal is to solve that angle ABD. The measurement of that angle is 15 degrees. So what we did next, it looks like we plugged in 7 into that x equation. So that would be a substitution. And it looks like we combined our like terms. We combined in 7 and 8 and got 15. So that would be a simplify. So you've noticed a lot of these proofs end up the same. We kind of use the same things over and over again, and even in the same pattern. All right, come to class with question, guys. I can't wait to